Hey everyone, how's each and every one of you are doing on this Tuesday evening? I hope that each of you are having a good week and keeping cool from the summer heat. Well, I'm on week 4, actually, we're there on week 5. However, I'm a little behind, like less than a week behind, but I will catch up eventually. So I already did the notes for the homework assignment. I already posted things on the Canvas website and beyond. So we'll send this on the website and through email as well. So bear with me for a second, okay? All right, for week 4, we're continuing from on radicals, and this time we are going to deal with simplifying radicals. Like last time, we did a little bit of everything. We did the radical and rational exponents, and this is a little step further. So remember these assignments like square roots. Remember, just for give you an idea what we're going to be doing today. And let's begin. The first problem on simplifying radicals is the square root of 24. I always do this first. First thing first is we're going to do factors of 24. It's going to help. Okay? What are factors of 24? We can use 3 and 8, 4 and 6, 12 and 2. Oh, I'm going to write this down. 3 and 8, 4 and 6, 12 and 2, 1 and 24. Put it on the side right here. You see right here on the left side. However, I could eliminate 1 and 24. 12 and 2 is between 3 and 8 and 4 and 6. However, the answer is the factors we can use is 4 and 6. It's because 3 and 8 will not work due to you got to make sure the actual factoring will work. I'm going to show you why. Factors of 24, we have 4 and 6, right? At any time, if you get if you're a little bit behind on the video, you're more than welcome to stop the video anytime. So you have my full permission, okay? All right, let's continue from there. We got factors of 24, 2, 4, and 6. As you can see right here, notice something between these two numbers. One of them is a square root. Which one is it? Four, right? So what's the square root of 4? 2, right? 2 times 2 is 4. So we got square root of 2 times 2. And when you do this, are we done on this part? Yes, we're finished. So let's go on to this portion. When you see this problem, you have to go, there is normally a number in front of the radical, and the radicand actually, and the number inside of radicand. So based on what we got the common number is 2, right? And this is 6. Can you see that? Wonderful. All right. What goes outside first? The 2 or the 6? Outside the radicand. Outside the root, actually. If you said 2, you're correct. Very good. All right. That goes outside, right? Inside is the 6. You want to check that out on your calculator, make sure? Let's see. You can use any graphing calculator or a scientific calculator to make sure you got the answer correctly. I hope you can see this. Can you see that? Square root of 24. 2 and 6. Square root 2 square root of 6. Does it match? Yes. So that is our final answer. Alright. So you see in this first part, every problem you're going to be dealing with, we're going to do factors. It's going to help you. It's going to eliminate a lot of the heavy duty work. And once you find the common numbers that best fits this puzzle we're working on, then you continue working from there and you check your calculator to make sure everything is right on point. But other than that, any questions on number 1? All right, let's move on to number 2. We have the 3 on the radicand, index of 3, square root of 1,000. All right, this was sometimes the reason why I have this problem is that there's one simple way you can do this. Care to guess? Anyone care to take a guess? What's the common number? If you said 10, that is correct. So we could rewrite this. A 1,000 as 10 cubed. All right? This is going to be significant. I'm going to tell you why in a few minutes. But this is how I got this. We got 10 times 10 is 100 times 10 is 1,000. So it's right beyond your calculator. So, but that's how you get 10 to the third, 10 cube or 10 to the third power. Any questions on this part so far? All right. Then we can bring down the index and the 10 over 3 part. Are we done yet? No, we're not done. We're almost done, but we're not done yet. What is common? What can we eliminate on this part? The 3's, right? We could eliminate cross those 3's out on the picture. And then what's left over is 10. Are we done? Yes, let's check it out. You see that? Does it match with that? Yes. So that is our final answer. Any questions on number 2? That wasn't too bad, right? So basically when you see this, the index is 3 and there's 1,000 inside a radicand, you can rewrite it as 10 to the third, 10 cubed or 10 to the third power. And then once you get that part done, then you can put the index and the square root, the radicand, and you put 10 to the third power or 10 cubed, and then you cross what's the common number that is you can eliminate is 3, and that's how you get the number 10. Any questions on number 2? All right, so far so good, right, folks? All right, forgive me on the different color pencils, but I want to make sure everything can be sealed, viable, and very important, okay? All right, number 3, the cube root inside the radicand negative 162. You'd be seeing a lot of these in your pre-calculus class this coming semester, this fall, this academic year, or any class, any time you're taking pre-calculus. This will give you something to work for and build from here. So bear in mind for a second, okay? All right. So we have factors of 162, of negative 162. Make sure it's negative. All right. What are factors of 162? First hand, what numbers comes into mind? 1 times 162. Let me see. 27 and 6. What else I can think of? Let me see. 3 and 54. Let me see. I can think of another way. 6 and 27. Okay, those are the numbers I thought of right off the bat, but we could eliminate some of them real quick. We could easily eliminate 1 and 162. Let me see. 3 and 54. Well, it's the same thing. 6 and 27. It's the same thing. The same. These two are the same, so forgive me on that. Let me cross this out. Don't worry about that. You can exit on your notes, but it's okay. All right, we could use 27 and 6 as our factors. Negative 27 and 6. All right, so far so good? All right, then we could factor out to 27. What numbers did we could easily factor out? 3 and 9, right? Negative 3 and a positive 9. Same notion on the 9. The square root of 9. What's the square root of 9? 3, right? But be both negative 3s. All right. We're almost done. We're almost done cleaning it up a little bit. I'm going to do this. That's our common number, right? 3, negative 3, and then the 6. All right. We could pull it out. So we got 3, negative 3, and 6. What goes outside the radicand? The negative 3 or the positive 6? The negative 3, right? So we have the negative 3 as our outside the radicand. And we'll put the rest of the problem here. And the 6 inside. Let's check. That is the actual fraction. Let's see. It won't let me go. Let me see. It's okay. But that's the answer. That's the answer is a negative 3. The radicand, the index of 3 squared over 6. So that is the answer. So that is the final answer. Any questions on number 3 on this problem? When you see a negative, you want to make sure that when you see the negative, make sure you keep the same sign when you do the factoring, and make sure that whatever goes first, it's going to be a negative no matter what. And then what's inside a radicand, whatever is a positive or negative, and whatever comes up, this is what it looks like in the final answer. All right. Any questions number 3 so far? All right. All right, let's move on to number 4. Number 4 is square root of 512. All right, we're going to do the same thing we'll be doing here. Factors of 512. What are factors? 1 and 5, 1 and 512. Let's see, 2, 56 and 2. Let's see if I could do 3. This is 3. 3 won't work. 4, yeah, 4 and 120. Okay, that's be it. So you got rack factors of 1 times 1 times 512, 2 times 256, and 4 times 120. All right. Obviously, we could eliminate the 1 times 512 and 4 times 120. You could do 4 times 120, but you want to make sure that it goes the smaller the number. It's because you want to get a smaller number or a bigger number. It could be evenly factor. So that's why I'm going to use 256 and 2. I'm going to tell you why. All right. So are we finishing this part? No. Which one is the square root? The 256, right? What is the square root of 256? Let's check on the calculator. I want to make sure you verify it's correct. 16, right? 16 times 16 is 256. Are we finished on this part? Yes. All right. Then what goes outside? The 16 or the 2? Outside the radicand? The 16, right? And the 2 go inside the radicand. Let's check right here. Because it never hurts to go and double check our work. Does it match? Yes. So we stop right there. Any more questions on this? On this part? So when you do this, like I've been doing on the work, want to make sure that you want to factor, make sure you set up the factors and make sure the numbers will work. And then once you find the common factors, and then you can work plug and play the missing pieces. But in this case, you got 16 outside the radicand, and inside the radicand is 2. But any questions on this problem? All right. Let's go on to number 5. Number 5, we said we had the fourth index, the radicand of 128 in today's power. So this is where it separates. When you see the variables, it separates a lot of things. It makes things a little bit longer, but it's not. First thing first, we're going to do the factors on 128. That's one we can do right off the bat, okay? We have 1 times 128, 16 and 8. What else? 4 and 32. No. Okay, let's try those. We got factors 1 times 28, 16 times 8, and 4 times 32. First thing right off the bat, we can eliminate 1 times 128. That's too big. And can we use 16 and 8? Yes. Can we use 4 and 32? It's going to be a little longer, but let's try this one with a square root inside. Okay? Just gave it away that part. What's the square root of 16? 4, right? Okay. Now, both sides is 4. Both sides is 4. Are we done yet? No. What is the square root of 4? 2. So this is our fourth. These are the fourth root inside the index. You see the inside the radicand, which is the index. That's how many times this any number has to show up. And how many numbers do we have? How many times the number 2 comes out? 4 times, right? All right. We have 2 to the 4th power. The number 2 comes out 4 times and times 8. All right. Then we have to factor out that. Any questions on this part? All right. So far, so good. Now, you see the n to the 8th power? We need to factor this. We need to factor this out. Okay? What can be rewritten as what? We know the base is n, and what's inside the n. We know it's 1 times 8 is not going to work. Let's try 2 times 4. We could rewrite it as this. Rewrite. All right. So any questions so far on this part? Now, I could do this. Let's bring the 2. Bring down the 2. I'm going to bring the 2. Let me put an arrow. I'm going to put an arrow on that thing. No problem. I'm going to bring down the 2. Bring down the 2 and the parentheses n square 4 times 8. All right. And we could put it over this. The 4th root. The 4th root as an index. All right. So far, so good. All right. Then we could do this in some other ways. We could do this. It's going to be simply as it can. We could can we put the 2n square outside the radicand? Yes, we can do that. So wait, 2n square. The 4th, we bring down this part here. So we got 2n square. That will be gone. So this will be gone. This will be still going to be, the index will still be here. I made a mistake on the worksheet, but forgive me on that. But you see the answer makes sense. So we have 2n square, the index of 4, the radicand, and what's left over? The 8. That's how you do it. So any questions on number 4? Number 5, actually. That's what it looks like on the paper. When you look over the paper, that's where it's going to show up. That's the final answer. Read this one. Give me a second. I'm going to make sure it's a little bit shorter and precise. Oh, this is a final answer here, folks. Any questions on number 5? On pulling out the variable and making it into a radical on this part. All right, let's move on. All right, we have number 8. We have, I have to write my notes. I want to make sure according to my notes. Okay, we have the third root inside the index, the radicand of 24m cubed. Always, we're going to do the factors of 24, right? That's the first thing we're going to do first. 1 times 24, 4 and 6, 3 times 8. All right. So, we could eliminate 1 and 24 right off the bat. What can we do 4 and 6? Possibly. But can we do 3 times 8? Remember, look at the inside the index. That's a key word, 3. The number 3. This can this factor work? Yes, we can. It can work. So we got factors of 24. We got 3 times 8. And we can factor out, let's see, the 8. What's 8? 2 times 4. And we do the same thing, 2 times 2. All right, here's a big, this is better. This, how many times the number 2 comes out? 3 times, right? What number do you see inside the index? 3, right? So we're almost done, right? So that's how you figure out the number 3 will come out. Any questions on this part, on this what I showed you just right now? All right. All right, we got 2. We got the number 2 and 3. What do we have left? M cubed, right? All right. There, we're almost done. We're almost done cleaning it up just a bit. So what number do we use outside? What number do we use? The 2 or the 3 outside the radicand? The 2, right? So we're going to put the 2 here. And what do we need to do next? Do we put this part next to it or leave it inside the radicand? We put it in with it, right? And then we have... No. I was wrong. Hold on. Give me a second. I made a boo-boo. I made a big boo-boo. My mistake. Because watch. This is inside and the 8. And the 3 actually. The 3 is the final answer. So this is actually it, because when you do the factors of M3, it goes to 1. And this is what it looks like when you factor it out. Oh, yes, it is. Yes, it is. So we have M and then 3. And this is how to get the M. My mistakes. I forgot this part. So when you factor out the M, you need to factor out the M3. And this will come out. That's how to get the M by itself. Because the number 3 shows up inside the index. And that's how you get the M. So you got 2M, index of 3, square root of 3. And that's our final answer. My apologies on that mishap. But you see how I got that part? So, any questions on number 8? All right, let's move on to 12. 12 and 15. 12, it's the same thing what we're doing earlier from number 3, right? But 3 doesn't have a variable on the inside. 12 does. So we have to be extremely careful with this. So we have the third index, square root of negative 16a cubed b to the 8th power. All right. First thing first, we have to do what? Factors, right? Factors of 16. We got 1 times 16, 2 times 8, 4 times 4. All right. We could eliminate 1 times 16. Can we use 2 and 8? Possibly. Can we use 4 times 4? No, because if we do fours, they're gonna be 2s. There'll be the number 2 will show up 4 times. But look at the index. We need what? 3 instead of 4, so we could eliminate this easily. Now we could work on this. Let's see, -16. We got -8 and 2. And what's the factor of 8? 2, 1, 4. And we got factors of 2 times 2. And how many times does it show up on number 8? 3 times, right? Okay. That will be easier that way, but the answer will come out a little bit iffy, okay? A little bit different, okay? But it'll all be negatives. Make sure. All right. There you go. Any questions on the factoring part? All right. Then we need to factor out the a cubed and b8. 8b to the 8th power, right? We're going to do this. We're going to leave the a3 alone. Yeah, we'll leave a3 alone for the time being. We're going to use the b8. So, what's the factors of b to the 8th power? We can do... Oh, we can do this. Can we try this? We could try b2 to the 3rd power times b squared. Because like 2 times 6 is 8. Add 2 more is 8. So that's how we use this as breaking down this part. Any questions on this part? All right. Now we can bring down the common number, which is 2. -2, right? -2. And then we have the... Then we could do this. We could open this up a little bit. Rewrite it just a bit. Hold on a second. Let me do this. I don't want to confuse the students. I don't want to confuse y'all. So we can do this. We can do this at open parentheses. Right? Bring down the -2. You see the a. You see the b squared. And the 3rd, right? Because, see, when you factor this will be -8, right? This one did this, -8, and then 3 b6, right? That's the first one. That's the scratch word. So this is the part we can use, okay? All right, that's how you check it. It matches with 8, so that is correct. Are we done yet? No. We're missing what number we were missing? 2, right? That 2 right here, right? And what's remaining? B squared, right? All right. See? This will happen here. So in order to get this, the first factor is -8. This is what comes out here as a check. And then it works. So we use this and 2b squared. Are we finished? No. Okay. It's going to make it a lot simpler, a lot easier for you folks, okay? All right. So you see that -2ab squared? That goes outside, right? Okay. Follow me here so far? This will you take it out from the terms. And then what's inside the radicand? The 3, right? So far, it looks good. And then the 2b squared, what's left over, right? And are we finished? Yes, that's our final answer. So when you do this, factors of 16, you break it down into what I brainstorm on this side. And then whatever you pick the numbers, the factors that fits into the factorization. And then when in this case, we have -8 and +2, and you factor out the -8, and you got the -2, -2 comes out 3 times as the index. Then 2 were left over on the other side. But once you got that part, then you need to factor out the a cubed and b to the 8th power. Then we don't have to do anything with the a cube, and you just factor out the b. In this case, you got open parentheses b squared, close parentheses, the cube times b squared. And then once you have that, then you bringing down the first part, which is the a, right? The -2a b squared, close parentheses, to the 3rd power, 3rd cube, and the 2b squared left over. And then you put in the missing pieces. This will go out first, the -2ab squared. You don't have to worry about the 3 because that's a clue right there. That's for the index. And then after that, you put the remaining inside the radicand. But I hope I'm explaining you the best that I can in this problem. But any other questions on this problem? All right, we are finished, almost finishing. All right, here we go. We have, this is a different index, which is the square root number 15. The 6 inside as inside the index. 448 x to the 7th and y to the 7th power. So this is a little bit longer. So watch and see. What are the factors of 448? I'm sorry. Tongue-tied. 1 times 448. 64 times 7. Let's see. Let me see if I could see. 2 and 224. I think that's it. Those 3. And we know that we can eliminate 4 and 448, and we can eliminate this part. So we left over is 64 and 7. Question, folks. Do you recognize which one is the square root? Is it a square root, actually? Which one? 64 or the 7? 64, right? What is the square root of 64? 8, right? So we have 8s here. Oh, let me get the spread out. And then, can we factor these 8s? Yes. Each one can do the same, right? 2 and 4. 4 is 2 and 2. You do the same thing with the next one. All right. What's the root index? 6, right? How many times the number 2 comes out? 1, 2, 3. 1, 2, 3. 6 times, right? So we have the 2 and we have the 7. We're almost done, okay? Now we can factor out this. X to the 7th, y to the 7th. We could do this. Hold on a second. I think we got it. We got x times 6 times x, y times 6, y 6 times y. So we have x to the 6th power times 1 times x, y to the 6 times y. And as we can factor these two out. And then we could do this. It's going to be a lot easier, actually. You'd be surprised. So we have 6 root. So what's left over? The x and the y, right? So that is we're missing pieces to this puzzle. So, any questions on this part so far before I go any further? All right. Then we could, you see that 2 right there? We're going to put the 2 right here on the inside of the parentheses. And what's outside what's the remaining? XY, right? And what's the common one? 6, right? Okay. Bear with me for a second, okay? Actually, it does work. Yes, my best. Let me correct this. Somehow I need to explain this better. Shoot. All right. You see the x to the 6, y to the 6? That's what goes inside the parentheses. And then the ones left over is 7xy. That's better. Whew. I made a mistake. So apologies on that. So when you see the x6 that goes inside the parentheses, and you put that over open and close parentheses of the 6th power, and then what's left over is 7xy. Question, are we finished yet? No, we're not finished. We're almost done. So I'm going to use, you see the 2, right? We're going to separate the 2 outside. All right. Then you see the xy. That could be used at what? Can we use the xy as part of absolute value? Yes, we can. You could be like this. The absolute value of xy, close parentheses. And what's remaining? 6, the index of radicand of what's left over? 7xy. Now, question, are we finished? Yes. It's a little bit weird, but when you look over your notes, this is kind of like I try to explain the best way as I can. But this is a little bit lengthy problems. From your Canvas on your homework assignment, it's a little bit longer like this. It's a little bit more extensive. But this is the best way I can explain it in this short video clip. So, but I hope I answer your question. Any questions on 15? All right, folks, we're finished for today's lesson on week 4. We did the continuation of simplifying radicals. and this will be scanned into your onto Canvas or Google Classroom. Right now I'm using Canvas because it's much more accessible than Google Classroom, but I do apologize for that if I have not posted anything. What I did, but I'm gonna try to even the plateau on that on both sites. But if you don't have any more questions, but if you do have any more questions, I'm sorry, please contact me, and I will gladly help you with any questions that need to be clarified. But until then, everyone, you have a wonderful, safe rest of your week. I will talk to you soon. Have a good one, folks.